3.2 is another maths question, so I've got the Arrhenius equation. Use this equation in your answer from question 3.1. So let's remind ourselves what we did in question 3.1. So in question 3.1 we worked out K, which was 0.028. So I can work out ln K, ln of 0.028 equals minus the activation energy. We don't know the activation energy, and I think that's what we've got to calculate. Calculate a value in kilojoules per mole for the activation energy, yes. 8.31 is my gas constant, so that's R. Temperature is in Kelvin, so if we have a look at the gas constant here, it's Kelvin. So 25 degrees C, add 273 on becomes 298. So I've got to get that into Kelvin, and then add ln A is 16.9. So in terms of maths, then the first thing I've got to do is I can work out ln 0.028, which works out at minus 3.58. I take the add 16.9 from the right hand side across the equal sign, it becomes minus 16.9 equals minus EA 8.31 times 298. The next thing I've done is I've calculated this, minus 3.58, take away minus 16.9, take away 16.9 is minus 20.48. Minus activation energy still, and I've multiplied these two out to give me 2482.6. To get minus EA, I'm going to multiply these two together now, and equals minus 50716. It's in joules per mole because my gas constant is in joules, so that's in joules per mole. I've got a negative and negative on each side, so I'm going to call it a positive on each side. Now I'm going to reverse the signs on each side, so EA equals 50716 joules. Joules going to kilojoules, a small unit going to a bigger unit, I divide by 1000. EA equals 50.716. However, I've rounded it to two significant figures because some of these values are to two significant figures, such as the temperature, 25 degrees C. So I always take my least accurate number, which is 25, and I go to that number of significant figures.